As technologies advance, generating electricity with wind turbines is becoming ever more efficient. Wind energy is successfully competing with other types of energy in terms of both cleanness and price. What is a wind turbine? A wind turbine is a device that converts kinetic energy from the wind into electricity. Wind turbines are manufactured in a wide range of shapes and sizes, but the most common design involves 3 blades mounted on a tower made of steel or a mix of steel and concrete. Increasing the height of a wind turbine and the length of its blades increases its capacity, which these days can reach 15 to 16 megawatts. How much electricity a turbine generates depends not only on its capacity, but also on the wind speed, the angle of the blades, and the density of the air. At higher altitudes, stronger winds form, so the higher a turbine, the more efficient it is. Air density is also important. When the density is higher, more energy can be generated. But wind turbines are designed to operate effectively in light winds as well. And when the wind is very strong or maintenance is required, they sometimes have to be stopped. How does a wind turbine work? There is a wind vane and a wind speed meter at the top of each turbine. Using the information on wind direction, the turbine rotates to face into the wind, and the wind speed meter sends signals telling the turbine when to start generating electricity and when to stop. To use the wind with maximum efficiency, the blades can also rotate around their axis. Wind flowing over the blades produces lift, which makes the rotor spin. The blades are connected to a hub and a low-speed shaft. They all spin at the same speed of 7 to 20 revolutions per minute. But for the generator to produce energy, it needs a faster rotational speed. That's why most wind turbines have a gearbox, which multiplies the rotational speed of the low-speed shaft by over 100 times. The high-speed shaft then rotates at a speed of up to 1,500 revolutions per minute. It is connected to the generator, which converts the kinetic energy into electricity. On turbines that do not have a gearbox, the hub is connected directly to the generator, and then the rotor and the generator both turn at the same speed. From the generator, electricity runs via cables installed in the tower to a transformer, where its voltage is increased, and finally is fed into the power grid to go wherever we need it. How do wind turbines affect us? A modern wind turbine generates about as much noise as a lawnmower. When proper distance is maintained from the nearest residential areas, the noise put out by a wind turbine combines with the ambient noise and is indistinguishable. You don't hear wind turbines any more than you hear a modern refrigerator operating. The choice of proper location and distance also avoids or minimizes any impact of the shadow wind turbines cast. Offshore potential. Currently, the majority of wind turbines are developed onshore. But there is also active development in the sea. Offshore wind farms are very important for achieving Europe's plans to become a climate-neutral continent by 2050. Offshore wind energy generation is not only clean, but is also getting cheaper. Offshore wind farms are competing successfully with new nuclear and gas power plants, so they have good prospects. In the future, the majority of power generated in Lithuania will be generated using wind energy. By developing this type of energy, we are creating jobs, helping reduce dependency on fossil fuels, and significantly contributing to climate change mitigation. At Ignitis Group, we are creating an energy-smart world.